Hey everyone, in this tutorial I'll be showing you how to use the CraftsLab DART-MS Spec or database builder tool, or database builder program I guess we're calling it. But this is a way for you to build your own in-house custom DART-MS Spec libraries to use with the NIST NIJ DART-MS Data Interpretation Tool. To start, I will show you just the NIST DART-MS Data Interpretation Tool. You can download it at NIST at data.nist.gov. It's a zip folder. You unzip it, and there is a batch file that you can use to run this software. I'll show another video where I actually showcase how to use the software, but for now, I just wanted to show you where to download the NIST NIJ DIT. But the main software of this video is the Crafts Database Builder. So this is available on GitHub. It's completely open source, so feel free to root around in it a little bit. But assuming you're not a programmer and you just actually want to use this code or use these programs, what you want to do is go to the GitHub and then click on code and then download a zip file. This will just download this entire repository, and then you can access it on your computer locally. What you'll notice is that these programs are written in R. And so in order to run these scripts, you need to have installation of R on your computer. To install R, you just have to go to cran.rproject.org and install your system appropriate version of R. I also recommend using the RStudio IDE. So this just sits on top of R, and it just makes working with R a little bit more intuitive. All the examples I'll show you today are using RStudio. But you must install R first before installing RStudio for this all to make sense. So install R, then you can install RStudio. And once you've done both of those things, and you've downloaded and extracted our Crafts Database Builder, this is what the folder will look like. There are some mass spectra that are in this folder. There's some source code that you don't need to necessarily engage with. Some scripts that we will run through, and then some metadata files. These are Excel sheets. So what these programs need in order to build your own custom database are some mass spectra and some metadata. So I'm going to show you the mass spectra first in this example database. Within the main folder, there are three subdirectories, each one showcasing mass spectra that were collected at different fragmentation levels, and the way the spectra are organized in this example are in 1, 2, 3 format, where 1 are the low fragmentation spectra, 2 are mid fragmentation, and 3 are high fragmentation. So in each folder we've got, in this case, 4 mass spectra, each with labels. They're all text files, and I'll open AF just so you can see it. And so this is our mass spectrum AF, measured at a low fragmentation level, and we have mass to charge ratios in our first column and intensities as our second column. Notice in this case they haven't been normalized, and that's okay when you're building a library. And I've got 4 mass spectra. If I go back a level in the second folder, I've got the exact same labels, but these are now different mass spectra. This is the mid fragmentation, so you'll notice that our base peak is actually no longer the 336 that it was previously, or 330. Yeah, now we've got a different set of peaks associated with the higher fragmentation level, and similarly for 3 we'll have the highest fragmentation level. So those are our mass spectra, and then these are our Excel sheets with the metadata in them. I don't have Excel installed on this computer, so I'm going to showcase these files on my Microsoft 365. But here is the basic metadata that is required if you're going to build a basic library. You need a code, which is just the file name minus the .text, but the file name of your mass spectra, the name of the compound that you'd like to use when you're building your database, and a target mass to charge ratio. So this is the mass to charge ratio that the DIT will be using to identify potential matches in the library. So let's say you're searching a mixture, and there was a peak in that mixture at 323.25. Assuming your mass tolerances are set correctly, one of the possible matches for that peak in your mixture will be acetylfentanyl, and actually benzylfentanyl as well, because the target MZs for those compounds are 323.212. Right, so these are traditionally, you'll likely set these to be the protonated molecule of your compound, but if you have some insider knowledge that that the compound is likely to fragment and there's another ion that's more likely to appear in a mixture mass spectrum, then that could be your target mass to charge ratio as well. So there's only 3 columns in a basic metadata sheet. In a full metadata sheet, you'll notice there are 7 columns. The code, same as the previous file, and also the name is the same as the previous file, but now we have a canonical smiles for each compound, and this canonical smiles is then used to generate potential target mass to charge ratios. So you're not having to input target mass to charge ratios, rather we're going to generate some based on these smiles, as well as the mass spectra themselves. There will be some information extracted from them. Additionally, you'll need these 4 columns, synonyms, IUPAC formal name, class, and contributor. You don't necessarily need data for any of these columns for your entries, but you need to have those columns in order for the programs to work. So 7 columns for the full, 3 columns for the basic. All right, so you've got your metadata set up and you've got your mass spectra collected. Then all you need to do is run one of your builder scripts. So we've currently have it broken down into 2 scripts. I would like to at some point bring them down and bring them into 1 script because there's a lot of redundancy, but that's a later me problem. But for now, let's say we're opening up our basic database builder script. I've double clicked it, so it's going to open it in RStudio. Just give it a second. And then it's actually quite straightforward to build a library. You've done the hard work of collecting the mass spectra and building your metadata file. And so in RStudio, you'll notice we have our scripts at the top, a console environment in our folder. This is my basic database builder script. I'm going to right click it and make sure that I'm in the right working directory. And then I'm just going to hit source. Now this is going to run my script. This is a basic builder with no quality checks. We're just uploading loading up some packages that are necessary. I do want to note that I've run this on my computer before, and so it loaded up quite quickly. If you're running it for the first time, there's a good chance that you don't have all the external packages that are necessary, and so R will ask you to install all of them. And so just follow along there. But okay, so we've got to the first prompt. There are 2 potential master files currently in the directory: basic Dart example library metadata and full Dart example library metadata. In this case, we're building a basic library, so we're going to pick our basic metadata sheet 1. There's only 1 folder of mass spectra, so that's great. And remember that this was organized in the 1, 2, 3 format, so that's, I'm going to type in 2 there, and that's great. And then I know these were collected with an AccuTOF with that tolerance. And then I'm going to call this basic for YouTube. Great. So this is how we build it, and then I hit enter, and now we're building our library, and that's it. It's super quick. One, because there's only 4 mass spectra in this in-house database, but it's also not trying to do anything fancy. It's not trying to generate target mass charge ratios. It's just taking what we give it. So do I want to create another database? No. And then that's that. I happen to also have the full database builder script open as well. And so I'll show how this looks if I run this. So again, now we're building a full database, so I'm going to make sure I pick number 2, the full Dart metadata. There's still only 1 folder for Spectra, so I'll pick that, and it's still structured the same way with the 1, 2, 3. Here now are some of the additional optionalities that come with the full database builder. In this case, we're using helium to collect the spectra, and they were collected in positive mode, still the same tolerance. We have the option of generating a collapsed or traditional library. In most cases, you'll want a traditional library. And then now I'm going to call this full YouTube. So this is our full database. So now, and let me spell full right just for the audience. Great. So now it'll take a little bit longer because we're generating structures for each compound. This is using the OpenBabel installation. Right, and that's the other thing. If you're building a full database, you have to install OpenBabel. You also have these additional packages like NVPAT that I'm using in Organic Mass Spec. And so these are all fine. They're all great, but it does take a little bit more effort to install and to use. So now the other options that are given to you with this full database builder is you can generate an SDF file, which allows you to use it with NIST MS search. We'll say yes, and then a molecular formula list that you can use with Mass Mountaineer. I'll say yes. And do I want to create another database? No. Perfect. So that's it. So I've generated a basic and a full database. And if I go to my folder here, you'll notice now I have a lot more. I have many more files than I had when we first started. So this is our basic YouTube RDS file. So this is the actual database that we'll be using with the DIT. The full YouTube RDS file, which is the other database that we can use with the DIT. Then we have the SDF file that can be used with MS Search, formula list that can be used with Mass Mountaineer. We also have some other quality checks as described in a previous article that kind of tell you a little bit about the structures and the spectra involved in that database in the full YouTube database. Before I move on, I want to show you one more thing, which is building now a database that's a slightly different structure. So I've got some spectra from my collaborators at Sam Houston State University. They've got a small library of fentanyl mass spectra. And the same thing, we've got the spectra and we've got some metadata. So I'm going to copy all of this over to my, Crafts Database Builder folder. There we go. And so now I'm going to build a basic library just to keep things simple for us. But before I do that, let me just go back here. And we have to look at the database structure, or sorry, the spectra structure. So this library is organized in low, mid, and high fragmentation levels, which I think is a good way to remember and to organize your data. But same thing where each folder has the same file names but different spectra, but those file names are attached to the compound name or to the compound. So now if I run my basic builder script source, you'll notice now it's noticing that there's 4 master files or 4 potential master files in that folder. So I'm going to build an SHSU basic DART fentanyl library. So that's number 3. I'm going to use the SHSU folder, which we know, sorry, I'm going to move my mouse so you can see the number, which we know is of the low, mid, high organization. And I happen to know that it's also 0.005 as the tolerance, and we'll call this SHSU basic fentanyl. And perfect. So our library has been created. I'm going to say no. If I go to my folder, I've now got my basic, there it is, RDS files. And I'm actually going to switch to type so we can see them all together. So I've got 3 new RDS files that I can use with the NIST NIJ DIT. But I'll show you how to add these folders or add these databases to your DIT in a following video just to keep things a reasonable time. Thank you all for watching, and yes, like I said, I'll have a follow-up video about how to use these databases with the DIT. Thanks.